Hi guys, welcome to our last learning target of chapter 4, which is I can write a standard form polynomial function given its zeros. So basically what we're doing is we are undoing what we've been doing for the past few days. Instead of finding zeros, our solutions to a polynomial function, we are given zeros in order to work backwards and write the polynomial function that those could have come from. So we actually already know how to write a polynomial equation given real zeros. So for example, write the polynomial function in standard form with the least degree and a leading coefficient of 1 that has the real zeros 1, 4, and -2. I want to remind you that if you have a factor of a polynomial, I'm just going to write this up here, if x minus a is a factor of a polynomial, then x equals a is a 0. Okay, so basically whatever our zero value is, if we want to put it in a factor, we always subtract it. And remember, when we subtract something, it changes the sign. So we have to remember that when we're given zeros, because we could always write the function in factored form, remembering that the factor is x minus the zero value. So in this particular one, we are given these zeros. So I could write f of x equals x minus 1 times x minus 4 times x minus a -2. And of course, we're not going to leave that as x minus -2. We write that as x plus 2. Okay, so with those three factors, I've started off. Unfortunately, this is factored form. This is not standard form. So to get to standard form, I need to multiply these all together. So I'm going to start with my first two binomials and distribute. So these two. That's going to give me x squared, and then I'm going to have minus 1x, and minus 4x gives me -5x, and then -1 times a -4 is a +4. And then I'm going to multiply that times x plus 2. Distributing my x squared gives me x cubed plus 2x squared. Distributing my -5x gives me a -5x squared minus 10x. And finally, distributing my 4 gives me a +4x plus 8. And I'm almost to standard form. I just need to combine like terms and make sure my exponents are in descending order. I have x cubed, and then 2x squared minus 5x squared is -3x squared. -10x plus 4x is -6x, and then plus 8. Sure enough, my exponents are going from highest to lowest, and I'm all multiplied out in standard form. Alrighty, so that was not too bad. The thing about it is now that we don't always have to have real zeros, okay? So we could have complex roots, which we've seen before. They could maybe be of the form 2 plus 14i or 2 minus 14i, which we write more simply as 2 plus or minus 14i. Now, where does I come from? Do you guys remember? I comes from taking the square root of -1. So remember, complex numbers are from taking the square root of a negative number. When we look at irrational roots, now while irrational roots are real, they're just irrational. So we leave them as a radical because there's no decimal equivalent since they're not perfect squares. So for instance, I have 1 plus rad 7 and 1 minus rad 7, which we could write as 1 plus or minus rad 7. Now, why do we have to have plus or minus, and why do we always have to have both of them? Well, the reason is these come from taking the square root, and every number has a positive square root and a negative square root. So that's where these next theorems come from. And I actually realized I have some typos in the irrational root theorem, so I'm just gonna like cross out some things and make it simple. So cross out literally the first 2.5 lines, and our big ideas is still there. So the irrational root theorem is this: if a plus b rad c is a 0 of f, then a minus b rad c is also a 0 of f. Similarly, the complex conjugate theorem is if a plus bi is a 0 of a polynomial equation with real number coefficients, then a minus bi is also a 0. So basically what this says is one of these does not come without the other. Reason being, they came from taking the square root of something, and when we can take the square root of something, we have to account for the positive and negative. So moral of the story, you're going to encounter some problems like letter A down here that might give you an irrational root or a complex root, and you have to understand that if it only gives you one of them, you have to account for either the other one, which might be the positive one or the negative one. Let's look at letter A. Write the polynomial function in standard form with the least degree and a leading coefficient of 1 that has the given zeros. Okay, so let's get started. I have f of x equals, if I have the 0 of positive 6, that comes from the factor x minus 6. If I have the 0 of negative 1, that comes from the factor x plus 1. But now I see I have the complex 0 of 2i. Now, 2i is the square root of some number, which means negative 2i has to be the other square root. So you have to remember to include that one, even though the problem didn't give it to you. So that means I have two more factors, x minus 2i and x plus 2i. All right, so we have our function started. Now all we have to do is multiply and put this thing in standard form. When we have factors that have real numbers and we have factors that have imaginary numbers, we want to multiply their like factors together before we try to combine forces, okay? So we're going to start with x minus 6 times x plus 1. Alrighty. So that's going to give me x squared, that's minus 6x plus 1x, so minus 5x minus 6. Now, when I multiply x minus 2i times x plus 2i, I get x times x, x squared. X times 2i we write as plus 2ix. Negative 2i times x is negative 2ix. And finally, negative 2i times a positive 2i is a negative 4i squared. Okay, let's see if we can simplify any of this. I'm still going to write x squared minus 5x minus 6. But my last set of parentheses, I have opposite terms here. My 2ix and negative 2ix, those actually cancel, so I have x squared. And then this minus 4i squared, we have to remember what I represents and what I squared is. To remember that I squared actually equals negative 1 because I came from taking the square root of negative 1. And we are never supposed to have I squared in an answer. So actually, this is equivalent to negative 4 times negative 1, which is positive 4. So I'm going to be writing in my factor x squared plus 4. All right, let's multiply and finish this thing. Distribute my x squared. Gives me x to the 4th plus 4x squared. Distribute my negative 5x. Negative 5x cubed minus 20x. And distribute my negative 6, negative 6x squared minus 24. And finally, combine like terms and put this in standard form. My greatest degree is 4, and that's just my x to the 4th term. Then I have negative 5x cubed. I have 4x squared and negative 6x squared, so that gives me negative 2x squared. And then I have minus 20x minus 24. And that is our final answer. Okay, we will do the other examples in class on Monday.